Okay, so let's try to graph this again. Let's see what you remember. When we're doing this, remember, this is what it should look like when you go to graph it. X cubed minus x squared. Remember, there's an actual squared key. Minus 4x plus 4. So we go to y equals, clear out whatever you had in there. So I go to y equals, clear out whatever I had in there. So I'm typing in x, which is right under the mode, right beside the alpha, caret 3, minus x. Then we got a squared, minus 4x plus 4, right? So I got that all there. And I go to graph because I just want to get a rough sketch of it. And my rough sketch, just like all the other ones, kind of looks something like that. Okay, so no problem. Just like before, you want to see what your graph looked like, so you press second graph, right? When you go to second and graph, we find our list of points. And remember, you can press up or down to find out where all of them are. Well, I see there's -3, -20. Well, that's not going to fit on there, so let's go down a little more. -2, 0 works. -1, 6 works. What else do we have? 0, +4, 1, 0, 2, 0. Let's scroll down here. And press down on there, and I get 3, 10, and 4, 36 is way too big, so -2, 0 goes right there, -1, 1, 2, 3, 4, 5, 6 goes right there, 0, 4 is 1, 2, 3, 4, 1, 0 is right here, 2, 0 is right here, and 3, 10 is up here. So I look back at my graph and I just kind of connect the dots on how the graph seemed to look. And there it is. Okay, so we take a look at this word problem. Basically what it's saying is I'm giving you a piece of cardboard. So here is your piece of cardboard. What it's saying is that it's 10 long and 8 wide. Okay? And you want to create a box out of that, but the only way you can create the box from what they're saying is you got to cut out corners that are x by x long, and you have to do that in every corner. You have to cut out corners that are x by x long. We don't be, and the reason why we're saying x by x is because we don't know how long we should cut them out for. That's why it's x by x. So what that means is this new length in here, let me change that to red here, the new length in here, to figure that out, that's actually pretty simple. It's a length of x and a length of x, right? So there's two x's, but the whole thing is 10, so that means it's really 10 minus 2x. And this length here, going the whole way down, it's x and x, but it's 8, so I'm taking 2 x's out of that, so that is 8 minus 2x. So I know the length and I know the width now. Okay? And we're trying to draw a box. And what that means is I'm going to cut those x edges out, right? I'm going to cut them out. I'm going to fold it up, which means the height of my box will be an x because I'm literally going to take those and fold them up. And I know that the base is 10 minus 2x, and back here that is 8 minus 2x. So I know the dimensions, and the reason why I need to know the dimensions is because the problem says what's the max volume, and volume is length times width times height, and we know that the new length was 10 minus the 2x. We know that the width was 8 minus 2x, and we know the height was x because when I fold the box up, that is the height, x. So when we distribute here, because I got to figure out what the equation looks like, I get an 80 and multiply that, I get minus 20x minus 16x and plus 4x squared. So when I combine everything that's alike, I get 4x squared. That's minus 36x, and that's plus 80. But remember, I also still have that x out in front, so I have to take that through to everything. And I'm just going to rewrite this up here. So I end up getting 4x cubed minus 36x squared plus 80x. That's what I end up having. So that's what you need to graph. So I want you to go in your graphing calculator and type in 4x caret sine 3 minus 36x squared plus 80x and press graph. Okay. The reason why I told you to graph this is the problem says what's the max volume. Okay, so I need to find the max volume of that. Well, the reason why I told you to graph this is actually very simple, because there's a function now in your calculator that can help you do this. But before you do it, let's make it simple. I want you to go to press zoom and make sure that you go down to Z standard for zoom standard. Make sure the graph is in standard form. What you notice is the graph comes out of the screen, but it comes back down and looks like this. So here's what you do. Very simple. You go to second, so press second and press trace, which is at the top. Second and trace. And you see how there's a list there, and one of them, which is number 4, says max. What I want you to do is press max, and you'll see that it's blinking right at 0, 0. I want you to press enter because it says left bound with a question mark. Press enter. Keep moving over until your x is, we'll say, around 3.6. So keep checking that out. Do you see the same blinking thing up at the top of your screen? The same blinking thing at the top of your screen is the right bound, so press enter. Then it says guess. Press enter one more time. And you end up getting something that looks like this. You end up getting x equals 1.47 roughly, and y equals 52.5, we'll just say. Here's what that means. If you cut out x as 1.47, okay, if you cut out an x of 1.47, and keep in mind x needs to be in between 0 and 4, which it is. If you cut out an x of 1.47, this right here would be your max volume, which is 52.5, which is the answer that you're looking for the problem. So what that helped you find out was the maximum value you could put x in to get out the maximum volume that you could possibly get out. And that maximum volume you can get out is 52.5. I know that one was a trickier problem to see, but I still thought you need to see a word problem to see how you could use that. So if you have any questions or concerns, please let me know, and we'll talk later.